When Captain Saburo Sakai's Mitsubishi Zero screamed through the humid Philippine sky on a clear afternoon in 1943, he believed himself untouchable. The Zero was the most lethal fighter in the Pacific, a machine that had dominated every engagement in the opening months of the war. Sakai himself was a living legend among Japanese naval aviators, a veteran of the China campaigns, a pilot who had claimed more than 50 enemy aircraft destroyed. His reflexes were poetry. His tactical understanding was encyclopedic. He had survived encounters that should have killed him dozens of times over. And yet, on that particular day, something began happening that no amount of experience, courage, or aerial genius could explain. He watched through his windscreen as American P-38 Lightnings pulled away from his formation at distances that made his guns useless. And then, impossibly, tracers began streaming back at him from those impossible ranges. One by one, his wingmen fell, burning from the sky. Sakai pressed his fighter harder, knowing that if he could just close the distance to within 200 meters, his own weapons would answer back with authority. But the Americans kept their distance. They refused to follow the geometry of air combat that Sakai had learned through 3 years of merciless Pacific warfare. They refused to play the game that Zero pilots had always won. This moment, repeated thousands of times across the Pacific theater over the next 2 years, represented one of the most significant transitions in aviation warfare. It was not born from exotic technology or secret weapons. The American pilots were not equipped with aircraft that flew faster or turned sharper than their Japanese counterparts. The ammunition in their magazines was no different from ammunition used by every other air force in the world. What changed everything was something far simpler, and yet, in its implications, far more profound: geometry. The way 650 caliber machine guns and one 20mm cannon were arranged in the nose of the P-38 Lightning created a convergence point that fundamentally altered the rules of engagement in the Pacific sky. While Japanese fighters inherited a legacy of wing-mounted weapons that forced pilots into the intimate dance of close-range dogfighting, the P-38's concentrated nose armament created a cone of devastating fire that reached out to distances where Japanese pilots could barely see their enemies. This was not innovation born from the drawing board of some visionary genius. It emerged almost accidentally from the collision between American engineering priorities and the particular demands of air combat in the vast Pacific. To understand how this advantage revolutionized the war in the Pacific, we must first understand what the American designers thought they were solving when they created the P-38. The Lightning was born from a 1,937 Army Air Corps specification that called for a high-altitude interceptor capable of reaching 360 miles per hour at 20,000 feet. The aircraft needed to carry enough fuel to patrol for extended periods and enough firepower to bring down enemy bombers. These requirements created a fundamental design problem. A single-engine fighter simply could not meet these specifications. The engines available in the late 1930s simply could not generate enough power while carrying sufficient fuel and weapons. The solution, championed by Lockheed's chief designer, Clarence Kelly Johnson, was radical: build a fighter around twin engines mounted on twin booms, with the weapons concentrated in a central nacelle between the engines. This choice in architecture, made for reasons of engine power and fuel capacity, inadvertently created something revolutionary. The nose-mounted weapons package meant that all 6 50-caliber machine guns fired along the same trajectory. When properly harmonized, meaning when a pilot set the convergence point correctly, all 6 guns would pour their fire into exactly the same place in space at a given distance. This meant that at 1,000 yards, a P-38 pilot could throw down a devastating pattern of fire that resembled the output of a medium-caliber cannon more than a fighter's machine guns. For comparison, a Mitsubishi Zero, with its 2 7.7mm machine guns and 2 20mm cannons mounted in its wings, could not achieve this convergence. The wing-mounted weapons had to be aimed at different angles to bring fire to the same target. When a Zero pilot fired at a distant enemy, His bullets and shells spread across a wider pattern. Killing shots were possible, certainly, but they required luck, exceptional marksmanship, and most importantly, they required the pilot to be in positions where wing-mounted weapons could be effective relatively close, within 300 meters ideally. Japanese intelligence officers, examining P-38 captured in the Philippines and dissecting them with technical precision, could see exactly what the American designers had done. They looked at the convergence of the machine guns. They studied the ammunition. They tested the ballistics of American .50 caliber rounds against the armor protection of contemporary Japanese aircraft. And here is where the Japanese discovered something that deeply troubled their understanding of air combat. The solution was not exotic. It was not a secret weapon or a revolutionary new ballistic technology. It was simple geometry applied to a practical engineering problem. The 6 machine guns fired standard ammunition, the same ammunition, in fact, that appeared in every other American aircraft equipped with .50 caliber armament. The rounds were efficient, but conventional. What mattered was not the ammunition or the gun technology. What mattered was that all the rounds converged into a single point at a distance where Japanese pilots had learned their instincts could not be trusted. The implications of this architectural choice became apparent only when the P-38 began appearing in the Pacific in significant numbers in 1943. American fighter pilots, trained differently than their Japanese counterparts and operating under different tactical doctrine, began to exploit this advantage immediately. Where Japanese pilots had been taught to close rapidly and engage in turning dogfights, combat styles that favored the Zero's superior maneuverability, American pilots learned to stay at distance, to maintain altitude, to use the P-38's speed and climb rate to advantage, and to pour concentrated fire into targets at ranges where Japanese weapons were barely effective. This represented a fundamental shift in the philosophy of air combat. For decades, air-to-air combat had evolved around the principle that victory belonged to the pilot with superior marksmanship, superior eyesight, and superior maneuverability in close combat. The Spitfire, the German Bf 109, the Japanese Zero, all were designed around the premise that fighters would engage each other in relatively close combat, where turning ability and visibility mattered above all else. The P-38, almost by accident, shattered this assumption. Major Richard Bong, who would become the highest-scoring American fighter pilot of the war with 40 confirmed kills, understood this advantage intuitively. Bong developed a tactical philosophy around the P-38's strengths, rather than trying to make it fit into the old model of air combat. He would use the aircraft's climb rate to gain altitude. He would use its speed to choose when and where to engage. Most importantly, he would use the concentrated firepower of the nose-mounted weapons to terminate engagements at distances where the enemy was nearly helpless. Bong's combat record, detailed in intelligence reports and combat debriefings, showed a pilot who consistently engaged at ranges that would have been considered impossible just 2 years earlier. His wingmen reported watching him pour fire into Japanese aircraft from distances of 800 yards or more, distances at which Japanese pilots could barely identify their attacker. The Japanese intercepted radio transmissions from these engagements. They read the combat reports of their own surviving pilots. They watched their best pilots fall to coordinated attacks from distances that violated everything they understood about air combat physics. Saburo Sakai's own combat experiences during the later part of the Pacific War provided Japanese commanders with documented evidence that the American advantage was real and systematic. In his autobiography, Sakai described repeated engagements against P-38s, where he found himself outgunned not because he was facing a pilot superior in skill or courage, but because the geometry of the situation was stacked against him from the beginning. He recalled an engagement where he pursued a P-38 that had attacked his formation. Sakai, knowing his Zero's superior maneuverability, expected that if he could just close the distance, he would be able to outturn his opponent and end the fight decisively. But the P-38 pilot understood this too. The Americans simply maintained distance, opened fire at ranges where it was almost reckless to attempt to shoot, and kept his airspeed high enough that Sakai could never quite close in. The P-38 pilot appeared to be wasting ammunition, firing at a target that should have been too far away. But the convergence of 6 machine guns at a distance of 800 yards created something that Sakai could not counter with his superior turning ability. The American could afford to hold distance. The Japanese pilot, with wing-mounted weapons, could not. This asymmetry, playing out in dozens of air combats every day across the Pacific theater, fundamentally changed the nature of the air war. The strategic implications became apparent in early 1943, when intelligence reports began crossing the desks of Japanese naval commanders, documenting the pattern of losses over the Solomon Islands and beyond. American fighters, previously considered inferior in many respects, were suddenly dominating enemy-controlled airspace. The Japanese had attributed early American successes to pilot experience and training. They had expected that as more Zero pilots with combat experience accumulated, American losses would mount. Instead, the opposite was happening. The arrival of P-38s in the Pacific was coinciding with the beginning of the end of Japanese air superiority. The gun convergence of the P-38, combined with the tactical doctrine that American fighters were developing to exploit it, was slowly turning the tide. The most dramatic demonstration of this advantage came on April 18, 1943, when a flight of P-38s intercepted Admiral Isoroku Yamamoto's transport aircraft over Bougainville. Yamamoto, the architect of the Pearl Harbor attack and the supreme commander of the Japanese combined fleet, was traveling to visit field commanders. American intelligence had intercepted the radio transmission confirming his itinerary. A P-38 flight, led by Major John Mitchell, was dispatched to intercept. When the American fighters found Yamamoto's twin-engine Mitsubishi G4M transport aircraft, they achieved complete surprise. The transport had fighter escorts, Zero pilots, who had no warning of the attack. The P-38s, diving from altitude with speed and surprise on their side, opened fire at distances far beyond where the Zero escorts could effectively respond. The Japanese fighters, positioned to defend against a close-range pass, found themselves attacked from ranges where their own weapons were nearly useless. One P-38, piloted by Lieutenant Thomas Lanphier, Jr., fired a burst at the transport aircraft at a range where a conventional nose-mounted installation would have been nearly ineffective. But the convergence of multiple machine guns created sufficient density of fire to damage the transport fatally. Admiral Yamamoto died when his aircraft crashed in the jungle below. The Yamamoto assassination, as the Japanese called it, sent shockwaves through the high command. More significantly, it demonstrated conclusively that the P-38's concentrated firepower could achieve results at distances that simply did not conform to Japanese doctrine. The aircraft carrying Japan's most important military leader had been downed by American fighters, employing tactics and weaponry that Japanese pilots were only beginning to understand. The combat report from the Yamamoto interception was analyzed and disseminated throughout the Japanese Naval Air Service. The message was clear. The American P-38 represented a fundamental change in air combat. Japanese pilots needed to adapt, but adapt to what? The problem was that the advantage was not derived from Japanese pilots making mistakes or from American pilots employing brilliant new tactics. The advantage was baked into the airframe itself, into the decision made years earlier by Kelly Johnson to concentrate all the firepower in a central nose-mounted installation. Japanese aircraft designers, working under wartime pressure and with access to some captured P-38s, could have attempted to redesign their fighters to incorporate similar nose-mounted weapons installations. The technical knowledge existed, the manufacturing capability existed, but doing so would have required fundamental redesign of aircraft that were already in production. The Mitsubishi Zero had been designed around a different philosophy, one that valued maneuverability and range over concentrated firepower. Changing this would have meant halting production of aircraft that were already obsolete compared to the P-38, but still in service and still useful. The Japanese military, by 1943, was no longer in a position to make such fundamental changes to their aircraft designs. The P-38 had arrived at exactly the moment when American industrial capacity was overwhelming Japanese production capabilities. Throughout 1943 and into 1944, the pattern of P-38 operations in the Pacific became increasingly systematic. American squadrons learned to use the aircraft's advantages to the fullest extent. Pilots were trained to use the P-38's superior climb rate and speed to disengage from fights where they were outnumbered or outmaneuvered. They learned to exploit the concentrated firepower of the nose-mounted weapons by maintaining distance and using the lightning's speed to choose engagement parameters. They learned that a P-38 pilot did not need to outturn a Zero to win. He only needed to stay out of range of the Zero's weapons, while his own guns converged fire at distances where the Japanese pilot could barely see clearly. Japanese commanders, facing this reality every day, began to develop counter-doctrines. They tried tactics where multiple Zeros would attempt to bracket an attacking P-38 from different angles, forcing the American to engage at close range. They tried to achieve surprise attacks from above, where the P-38 might not see them coming. These tactics sometimes worked, sometimes resulted in the loss of more Japanese aircraft. The convergence advantage of the P-38 also affected tactical squadrons in ways beyond the simple mechanics of who could shoot whom at what range. American pilots became more aggressive because they understood that their weapons were effective at distances where they could maintain energy and maneuverability. Japanese pilots, forced into close engagements by the nature of their wing-mounted weapons, found themselves fighting defensive battles where retreat meant presenting their vulnerable rear fuselages to American fire. The psychological impact of this asymmetry, playing out in combat after combat across the Pacific, slowly eroded the confidence of Japanese pilots who had previously believed themselves untouchable. By the time American forces reached the Philippines in late 1944, the P-38 had become the dominant fighter in the Pacific theater. The aircraft's ability to conduct extended patrols over vast distances, combined with the concentrated firepower of its nose-mounted weapons, made it nearly unstoppable against Japanese fighters. Major Richard Bong's final victories came during the Philippines campaign, where he ran up his impressive score against Zero pilots who were becoming increasingly desperate. Bong's combat tactics were pure P-38 doctrine. Maintain altitude, maintain distance, use speed to avoid close engagements, and rely on the convergence of nose-mounted weapons to terminate fights at ranges where the enemy was nearly helpless. What is remarkable about the P-38's advantage is that it was not rooted in breakthroughs in metallurgy, propulsion, or ammunition technology. American .50 caliber rounds were conventional weapons, effective certainly, but not fundamentally different from the weapons carried by other air forces. The German Bf-109, the British Spitfire, the Italian Macchi fighters all encountered American aircraft armed with .50 caliber guns. What made the P-38 different was not the weapon itself, but the way the weapons were arranged. This represented a kind of innovation that is often overlooked in military history. Innovation born not from inspired genius, but from practical engineering, problem-solving. Kelly Johnson had not set out to revolutionize air combat when he designed the P-38 around twin-boom, nose-mounted armament. He had simply been trying to solve the practical problem of how to build a fighter aircraft that could meet specified performance requirements. The revolutionary implications of his solution emerged only when American pilots began operating the aircraft in the Pacific and discovered that the geometry of the gun arrangement conferred an unexpected tactical advantage. Japanese intelligence reports from late 1944 document the growing recognition among Japanese commanders that they had fallen behind in the fundamental nature of fighter aircraft design. Japanese aircraft designers proposed numerous modifications to existing aircraft to incorporate nose-mounted weapons installations. The Zero was studied with an eye toward reducing wing-mounted weapons in favor of a concentrated nose installation. The Nakajima Hayabusa fighter project included proposals for concentrated nose firepower, but by this time, resources were scarce, production lines could not be readily adapted, and the war was beginning to turn decisively against Japan in every theater. The convergence advantage of the P-38 had arrived at a moment when Japan could no longer respond with equivalent innovations. American industrial capacity, already overwhelming Japanese production capabilities in raw numbers, had now also opened a qualitative gap in fundamental aircraft design that Japanese engineers could not close. The story of the P-38's convergence advantage is ultimately a story about how seemingly small engineering choices can have enormous consequences in warfare. American designers chose to concentrate firepower in a nose-mounted installation for practical reasons having nothing to do with air combat theory. That choice, made in the context of 1930s aircraft design problems, created an aircraft that was superb for the specific challenges of Pacific warfare. The advantage was not overwhelming. The P-38 did not make Zero pilots irrelevant, but it was decisive enough to matter when multiplied across thousands of engagements over 2 years of intensive air combat. Japanese pilots like Saburo Sakai recognized the problem almost immediately. The evidence was written in the combat records of every day. American fighters could stand off at distances where Japanese weapons were useless. Japanese pilots had to either accept being attacked from ranges where they could not respond, or they had to close rapidly, abandoning the advantages of altitude and energy in hopes of achieving a close-range turning fight. Increasingly, as American pilots became better trained in the doctrine of their aircraft, Japanese pilots found that even close-range engagements became desperate struggles. The P-38's speed meant that American pilots could escape from close fights if they were losing. They could disengage, climb, and re-engage on their terms. The Zero could not match this performance. It could outturn the P-38, but turning advantages mean little if one pilot can choose to disengage and the other pilot cannot prevent it. By 1945, the Pacific Air War had been almost entirely transformed by the evolution of American fighter tactics built around the P-38's advantages. Japanese aircraft production had been reduced to a fraction of earlier capacity. Japanese pilot training had suffered because experienced pilots were being lost faster than they could be replaced. American pilot training, by contrast, had improved steadily. American pilots were emerging from training schools with hundreds of hours of experience. American fighter squadrons could afford to lose pilots and replace them with trained replacements. The convergence of all these factors, the P-38's nose-mounted weapons advantage, American tactical doctrine built to exploit it, American industrial capacity, and American pilot training superiority, created an asymmetry that no amount of Japanese tactical innovation or pilot courage could overcome. The irony is that the technological advantage that allowed American fighters to dominate the Pacific was not particularly advanced or exotic. The .50 caliber machine gun was conventional. The P-38's design was clever but not revolutionary in any specific component. What made the difference was the way American engineers had arranged the components to solve a specific engineering problem. That problem-solving approach created an aircraft that was particularly well-suited to the demands of Pacific air warfare. Japanese fighters, optimized for different problems for the short-range dogfights of earlier air combat theory. For the air defense of the Japanese homeland, where range was less critical, found themselves suddenly operating under rules that had changed. The geometry of the P-38 had rewritten the rules of engagement in the Pacific sky, and Japanese pilots, no matter how skilled or courageous, could not overcome that geometric advantage through tactical innovation alone. When Saburo Sakai's autobiography was published after the war, it contained vivid descriptions of engagements against P-38s where he found himself at a tactical disadvantage despite his superior flying skills and experience. These passages have become some of the most cited accounts of how the P-38 changed Pacific air warfare. Sakai's accounts are notable not for describing dramatic differences in aircraft performance, but for documenting the frustration of a skilled pilot finding himself unable to close with an opponent who refused to fight according to the rules that Sakai had learned through years of victorious air combat. The American pilots, flying P-38s, understood that they did not need to match the Zero's maneuverability. They only needed to maintain distance and let the convergence of their nose-mounted weapons do the work. This realization that victory in air combat could be achieved through superior firepower at distance rather than superior maneuverability in close combat represented a genuine revolution in aerial warfare. The legacy of the P-38's convergence advantage extended far beyond the Pacific War. Aircraft designers worldwide began to recognize the value of concentrated nose-mounted weapons. Later, fighters, from the North American P-51 Mustang to post-war designs like the Lockheed F-80 Shooting Star, incorporated nose-mounted weapons installations for similar reasons. The principle that fighter aircraft should carry their weapons where they could achieve convergence at useful ranges became standard doctrine. German designers, examining captured P-38s and observing American tactical success, also moved toward nose-mounted weapons in their later fighters. The geometric advantage that the P-38 had demonstrated would influence fighter aircraft design for the next several decades. In the context of the Pacific War specifically, the P-38's nose-mounted weapons advantage was particularly devastating because it coincided with the moment when American industrial capacity was beginning to overwhelm Japanese production. In 1943, when the P-38 began arriving in the Pacific in significant numbers, American aircraft production was ramping up to levels that Japanese industry simply could not match. Every P-38 that rolled off the assembly line represented not just an individual fighter aircraft, but the concentration of American industrial might apply to the problem of air superiority. The fact that the P-38 was not just another fighter, but represented a fundamental architectural advantage over Japanese designs meant that the quantitative American advantage was being reinforced by qualitative superiority. Japanese pilots and commanders could argue about tactics, about doctrine, about the need for better training or different strategies. But they could not change the basic fact that the American fighters could stand off at distances where Japanese weapons were ineffective and pour concentrated fire into Japanese aircraft. That geometric truth, played out thousands of times in combat between 1943 and 1945, helped turn the tide of the Pacific War. The story of how the P-38 came to dominate the Pacific is ultimately a story about how engineering choices made in the bureaucratic context of aircraft specification and design requirements can have implications that reverberate through the course of a war. Kelly Johnson, designing the P-38 for the Army Air Corps in the late 1930s, was not thinking about the Pacific War or about Japanese Zero fighters. He was solving engineering problems. But the solution he created, a twin-boom fighter with nose-mounted weapons, proved to be ideally suited to the challenges of warfare in the vast Pacific distances. Japanese pilots learned this lesson the hard way, through repeated engagements where they found themselves outgunned at ranges where their own weapons could barely respond. The convergence of 6 50-caliber machine guns in the nose of the P-38, combined with American pilot training, American tactical doctrine, and American industrial capacity, created an advantage that was decisive. By the final years of the war, the P-38 had become the symbol of American air superiority in the Pacific, and the principle of concentrated nose-mounted armament had become the standard for fighter aircraft design worldwide. It was an advantage born not from exotic technology or brilliant innovation, but from practical engineering and the geometric properties of concentrated firepower. That simplicity made it all the more devastating.